Okay, so this first problem we're going to do is a roller coaster's initial speed at the top of the hill is 10 meters per second. 3 seconds later, it reaches the bottom of the hill with a speed of 26 meters per second. What was the average acceleration in meters per second squared? So the first thing that I'm going to do is underline what they're asking me. They're asking for average acceleration. So I'm going to write that equation down now, which is acceleration equals the change in velocity divided by time. And this gets abbreviated as A equals delta V, so acceleration equals change in velocity all over t for time. Now this change in velocity is actually standing for final velocity minus initial velocity all over time. And a lot of times you'll see this equation with a delta t as well, which means the change in time. So you would have a final and initial time. But for what we're doing right now, we won't have any of those. So we're just going to keep it as time. So now we have our equation. And I'm also going to write down everything that I'm going to need for this equation. So the variables, vi, which is v initial, the initial velocity. We also need to know the final velocity, which is vf, and we also need to know time, which is just t. So these three variables I need to figure out acceleration. Okay, so now we're going to read the question and highlight all of the key phrases and numbers that we need. So a roller coaster's initial speed at the top of the hill is 10 meters per second. So this phrase of initial speed at the top of the hill is 10 meters per second. So they gave you the phrase initial. So they've pretty much told you that the initial velocity is 10 meters per second. A lot of times they use the word speed and then give it a direction because velocity is a vector. A vector is a number that has a unit. So it's a number, a unit, and a direction. So they gave us the number 10. So I have a number. They gave me units of meters per second squared. So I have a number, my units, and a direction at the top of the hill. Because eventually it's going to the bottom of the hill, right? So it's from top to bottom. That's a direction. So velocity and vector, you can kind of remember they both start with v. So velocity is always a vector. It's a number, a unit, and a direction. My initial velocity is 10 meters per second. Then they tell me 3 seconds later it reaches the bottom of the hill. So 3 seconds later is my time. So I'm going to write that down here, 3 seconds. It reaches the bottom of the hill with a speed of 26 meters per second. So they didn't necessarily say final, but they don't have to. Because if we draw a picture of the problem, so let's say I've got my roller coaster. So its initial speed at the top of the hill, so right here, is 10 meters per second. That's its initial velocity. So this roller coaster is going 10 meters per second. And then 3 seconds later, it's now at the bottom of the hill. And it has a different speed. It now has a speed of 26 meters per second. So initial just means what its starting speed was, and its final velocity is essentially its ending speed. And the only reason that these speeds are called velocities is because it has a direction. It's starting at the top and then going down to the bottom. So that makes it a vector quantity because it's a number, a unit, and a direction. Okay, so I need to start drawing on different layers so that I can keep this work. Okay. So I'm going to write my final velocity is 26 meters per second. So now I have everything that I need to solve this problem. And my equation is right here. So I'm going to start filling in those numbers. Acceleration equals final velocity. So I look down here, my final velocity is 26 meters per second, minus my initial velocity, which we know is 10 meters per second, all over the time, which we read in the problem to be 3 seconds. Okay, now if you notice, they want it in meters per second squared, and they're already in meters per second, and my time is in seconds. So I don't have to convert on this problem, which is very nice. And because this is in seconds, and all the others are in seconds, I can go ahead and just subtract and divide. I don't have to do anything special on this problem. So I'm going to go ahead and subtract 26 from 10, which is 16 meters per second over 3 seconds, and 16 divided by 3, which is 5.3. And now my units are going to be meters per second squared. And let's look at why this is. So if you notice my units right here, I have this divide line. That divide line actually means that the seconds is on the bottom. So I could rewrite this. I could have written this as 16 meters over 3 seconds times seconds. This divide line means that the second right here is really on the bottom. You can just write it 2 different ways. But if you do write it on the top, you have to know that it in reality is on the bottom, so that when you get your units, it's meters over seconds times seconds, which is seconds squared. So let's really look at these units because units can tell you a lot. So acceleration is always a length divided by a time squared. So this could have been kilometers per hour squared, or meter or miles per hour squared. Those are still accelerations because they're a length divided by a time squared. Our velocities all have meters per second, or a length divided by a time. So this could have been miles per hour or kilometers per minute. So anytime I see a length divided by a time, I know that it's a velocity, which can make these problems easier because I don't even have to read the problem. All I have to do is look at these units. So if I saw meters per second and I know that a length divided by time is a velocity. All I have to know now is which number came first in the problem. And so I know that my final velocity is going to be 26 because it has a length divided by time. Seconds is always time, or it's hard to describe because a time is a time, but it could be minutes, it could be hours, but whatever time you have is always just going to have that one unit of time. Seconds, hours, minutes. And that is why knowing your units is so important. So, in conclusion, my final answer was this 5.3 meters per second squared. That is the average acceleration of the roller coaster.